Okay, last little problem. They've stopped the drilling in the wall. Is any of you familiar with Bob Dylan's Lily, Rosemary, and the Jack of Hearts? All right, the festival was over. Anyway, so now let's take a look at this problem. Suppose the horizontal velocity of the wind against the sail is 5.9 meters per second, parallel to its front surface, and 3.2 meters along its back surface. Okay, so its back has more pressure than the front, so therefore it's going to push it. In other words, if it's cruising along, and let's say the front surface is to our left, we're sitting in the sailboat and we're looking to the left. Let me draw what I'm talking about here. Okay, so we got to kind of draw this a little cattywampus. But so here's the sail right here. All right. So I got to kind of make it so that it's kind of in perspective here. All right, so the back, this is the front. All right, this is the front right here. And the back is back here. All right, so the back is back here. And the wind blowing across here is going, what did they say, 5.7 seconds, 5.9, 3.2. All right, and that's all they give us besides the air density. So this is 5.9 meters per second. And across the back, on the back side, it's 3.2 meters per second along the back. Okay, so we'll just call this V2, and this is V1. All right, and we're looking for the change in pressure. So this is a side view, or a straight-on view. Here's the straight-on view. So if this is the front and this is the back, there's more pressure on this side. So you've got the pressure going here, the change in pressure going that way, and the change in pressure is equal to a force per area. All right. So if we wanted the entire sail, if we took the entire sail, we would find, I shouldn't have put the meters per second, I should just put force per area. But our problem, this problem is just acting, what's the force acting on 1 meter squared? Damn it, here comes the pounding again. Well, this is pretty straightforward, actually. This is real straightforward. So let's do some of the work over here. So we know that energy is conserved. So we got P1. And since we're going to say it's all at about the same height, we're not going to worry about the height of the sail, the change in the height of the sail. Okay. So we've got P1 plus 1/2 rho V1 squared is equal to P2 plus 1/2 rho V2 squared. Now, I'm just saying that rho GH is equal, 1 is equal to rho GH2. All right, so those two pressures cancel. All right, so now what are we after? I want the change in pressure, so I'll bring P1 over here, subtract P1 from both sides, and I wind up with P2 minus P1, and I'll bring this guy over to this side, is equal to the change in 1/2 rho times V1 squared minus V2 squared. Since I know what those are, I can find that change in pressure. All right, and so I wind up with 1/2 the density of the air times V1 squared minus V2 squared is equal to my change in pressure. Okay, and that's in per, and they just want it for 1 meter squared. All right, so we're done. We've got 1/2 times 1.29 times 5.9 squared. 5.9 squared minus 3.2 squared is equal to my change in pressure per meter squared. All right, for 1 meter squared. All right, so I got 0.5 times 1.29 times 5.9 squared minus 3.2 squared. And that's equal to 15.8. That's 15.84 pascals per 1 meters squared. Okay, so that's 15 divided by 1, so that's 15 newtons. All right. Now, what if my sail, let's say my sail is 2 meters by 1.5 meters. Okay, so my sail is 1.2 meters times 1.5 meters. So I got 2 times 1.5, which comes out to be 3.0 meter, 3 meters squared. Okay, then the amount of newtons of force that are happening. So I know my change in pressure per 1 meter squared is equal to that. So my change in pressures per 3 meters squared, it will be, so I've got this. I came up with this term here is 1584, and that's a pressure. So 1584 pascals times the total area now is 3 meters squared. That'll give me a much bigger force. So the bigger the sail, the bigger the force I'm going to get. Does that make sense? Sure it does. So I got 15.84. 15.84 times 3 in this case, because of the size of the sail. So it's 47.5 newtons. So remember, F is equal to my change in pressure times A. And they said that A in this case was 1 meter squared. Okay? Clear as mud? Hope so. That wasn't too bad. All right. Well, you probably want me to put in the answer, see if it's true. 15.84. Oh, hell yeah. Okay, cool.